Okay, in this lesson we will start solving the sample problem 6G. In the figure 6.28 and in this figure, find the reading of the shown ammeter and the voltmeter and the phase difference between VR and V total, phase angle difference theta, if V total effective is 30 volt, and there are 1, 2, 3, 4, 5 voltmeter, V total effective is equal to 30 volt. This is given in the question. XL, yani inductive impedance, is 14 ohm. XL is, so let me write here, XL is 14 ohm. XC is 5 ohm. In the question, these values are given. R is 12 ohm. And the frequency of the generator is 50 hertz. We will find reading of all these 1, 2, 3, 4 voltmeter and 1 ammeter. So this is a series RLC circuit. We know that in series circuit electric current is constant. Yani electric current of the circuit is equal to electric current on the capacitor, electric current on the coil, electric current on the resistor. These are equal. So then we should start with finding the electric current, so then we will find the reading of this ammeter too. But before knowing that, we should use Ohm's law. For using the Ohm's law, so you should first calculate what is the total impedance of this RLC circuit. You know, what is that? We should first find this. So after that, we will use the Ohm's law for calculating the electric current of the circuit, because effective total potential difference effective is given. Electric potential difference between this point and that point is given as 30 volt. So first let's get Z. We know that Z is equal to square root of R squared plus XL minus XC squared. So this is the total impedance of the circuit. So because all R, L, and C given, so then that's why we can insert them into the equation. So R is 12, square root of 12, plus XL minus XC, 14 minus XC5, but squared. And then after that, let's get the square root. So then use your calculator. First get 14 minus 5, it is 9. Square root of 9 plus 12 squared, answer is 225. After that, get the square root of answer, which is equal to 15. So total impedance of this RLC circuit is 15 ohm. And now we can use Ohm's law because we know how much the potential difference, total potential difference between this point and that point, because it's equal to 30 volt. So then I will use Ohm's law for calculating the electric current. So then I will find the reading of ammeter by the time V total effective divided by Z. Total effective is 30 volt. Z we already calculated 15. If we divide them, answer is 2 ampere. So this ammeter measures 2 ampere electric current. We found it. Next step is to calculate the reading of voltmeter connected to capacitor, reading of the voltmeter connected to the coil, reading of the voltmeter connected to the resistor. We will find them one by one by using Ohm's law again. So we know that V, let's start from the capacitor, Vc is equal to, because electric current is constant in a series circuit, so this electric current is the same. So if we calculate this electric current by capacitive impedance, we can calculate the reading of the voltmeter connected to the capacitor. So then 2 multiplied by XC is 5, which is equal to 10 volt. So then reading of this voltmeter is going to be 10 volt. And then we go with the others, the voltmeter connected to the coil, VL. Again, electric current is the same because the same electric current again in series circuit flows through each element. So I multiplied by XL. I is 2, XL is 14. So then when we multiply them, we got it 28 volt. So this voltmeter reads 28 volt. And then finally, we will calculate what is the reading of voltmeter connected across the resistor. Again, Ohm's law, I times, but this time we will use the resistor because opposition of the resistance to the electric current is resistance. 2 multiplied by resistance of the resistor is 12, which is equal to 24 volts. So then this is 24 volt. We got the reading of 3 voltmeters, 1 ammeter. And then last one. What is VLC? Now this voltmeter is connected across the terminal of capacitor and inductor. So then we will calculate the total potential difference across the capacitor and inductor. To find this, we need the phasor. In series circuit, let's remember the phasor. If this is the electric current, it's the same for all elements. So resistor will have this, the potential difference across the resistor will be in phase, but potential difference across the coil will lead the electric current, so by 90 degree. But potential difference across the capacitor will lags behind the electric current by 90 degrees. So this is VC. As you see, VL and VC are opposite vectors. VL is how much? We just calculated. VL is 28 volt. VC is how much? Which is 10 volt. So then are they opposite vectors? Yes. So how can you calculate the resultant of these two vectors? By subtracting. So then VLC, which is the potential difference across the capacitor and inductor, will be 28 minus 10 volt. So which is equal to 18 volt. So then this voltmeter will read an effective value which is 18 watt. This is the solution of this sample problem. Now we will continue with the ministry exam questions asked in ministry exams till now. I will put them in some order. So the first question is, given an AC source connected to a pure resistor and the pure self-inductance of inductive impedance 61 are connected in series. Yani a resistor and a coil are connected in series according to this question. So XL is given as a 61 ohm. This is given in the question. And if the phase difference angle between the electric current and the total potential difference is 26.57, find the resistance of the circuit, calculate R. This is the question. So we will use the equation for phase angle difference. We know that tangent theta, phase angle difference in a circuit, RLC series circuit, is XL minus XC divided by R. Because there is no capacitor, so XC is equal to 0, and then you will say that tangent theta must be equal to XL over R. Because R is asked, cross product, so then R is going to be XL divided by tangent theta. XL is 61. Tangent theta is given in the question, which is 0.5. Tangent 26.57 is given as 0.5. If we divide 61 by 0.5, so let's divide it, 61 divided by 0.5, which is equal to 122 ohm. So 22 ohm, which is the choice D. Next question. The circuit shown in the figure, in the circuit, is the resonate circuit. Now in the resonate, what does resonate circuit mean? We will study after this topic. Maybe accidentally I put this question here, but in resonating circuit, XL and XC are equal. So that's why, according to the inductive, the total impedance equation, R squared plus XL minus XC, so this is going to be 0. That's why Z is going to be R. So for a resonating circuit, don't forget Z is equal to R. And we will talk about it later. So this is a resonant circuit, which means Z is equal to R. R is given in the question, which is equal to 22. So that's why Z must be equal to 22. If the effective potential difference of the source, V effective, is given as 220 volt, and the frequency of the generator F is 60 hertz, so what is the equation of instantaneous current in the circuit? So equation for electric current is, for a resonating circuit, Im sine omega t. So to write the equation, you should insert these constants, Im and omega, into the equation. Let's calculate first omega. Omega is 2 pi f. So 2 pi multiplied by f is 60, which becomes 120 pi. This is omega. And we need to calculate what maximum current. But first, let's get effective current. Effective current is equal to V effective divided by Z. V effective is 220 divided by Z is 22, which is 10 ampere. But in equation, we should write maximum current. So to get the maximum current, we will multiply effective current by root of 2. So 10 multiplied by root of 2, which is almost 14.14 ampere. Then we are going to insert these numbers into the equation. So I is equal to, Im is 14.14, sine omega is 120 pi t. So this is the equation. The choice is D. And let's continue with the question 3. An AC source is connected across a series combination of a coil of certain resistance, an inductive impedance of 20 ohm, and pure resistor of 10 ohm. And there are two there are two elements, in fact. But this coil is not pure. If it says you, it's a coil of certain resistance, which means this coil is not pure and this coil has a resistance. That's why I am going to represent it by XL, and also this coil will have a resistor RL. This belongs to the coil. So this true value belongs to this unpure coil. And after that, we connected a second resistor, a device, a series resistor, pure resistor, in series with this coil resistor, pure resistor, pure resistor. So then, this pure resistor is given 10 ohm, and XL is given inductive impedance is 20 ohm. So if the total impedance of the circuit is 25, which is Z is given, this is Z, what is the value of the resistance? Calculate RL. What is value of the resistance of the coil? We'll find this. Now, in fact, we can think that these two different resistors connected in series. If two resistors are connected in series, you should calculate their equivalent. So remember, in the last year you learned that if two resistors are connected in series, R equivalent is calculated by R1 plus R2. Here are two resistors, that's why I should calculate R equivalent as RL plus R. So then in equation I will insert R equivalent, not RL only, not R only. So then Z equation will be like this. Square root of R equivalent, which is RL plus R squared, plus XL minus XC. Because there is no XC, I will just write XL. XL squared. After that, you are going to insert the values. Z is 25. 25. Let's get the square. and get rid of square root. So 25 squared is equal to RL plus R, which is 10 squared, plus XL squared, which is given as 20. And then continue mathematical operations. RL plus 10 squared is equal to square root of 25 is 625. Square root of 20 is 400 minus 400, which is equal to 225. So RL plus 10 square is 225. After they get the square root of this both side, so then RL plus 10 becomes square root of 225 is 15. So then RL becomes 15 minus 10, which is 5 ohm. So then RL is 5 ohm. This is very frequently asked questions to me because you don't remember how to calculate two resistors if they are connected in series, and even you don't know these two resistors are in the series. They are series. So then ampere coil will have a inductance and also a resistance, because it's ampere, not pure. That's why we will assume that these two resistors are connected in series, and then we will calculate equivalent resistance by adding them. There will be other questions in the same manner. We will repeat this a few times and you will learn better. Fourth question is an example similar to this one. In an AC series circuit, if total resistance is 200 ohm, XL is 600 ohm, and XC is 400 ohm, and the total potential difference in the circuit is by a phase difference of blah blah the current. So then you will calculate theta. What is theta? Phase angle difference is what? Equation for phase angle difference is that tangent minus 1 XL minus XC divided by R. So then theta is equal to tangent inverse. XL is given in the question 600 minus XC is 400 divided by R is 200, which is equal to, this is 200 divided by 200, which is 1. The angle whose tangent is 1 is 45 degrees. So because it's positive means potential difference is leading the electric current. That's why we said the total potential difference in the circuit leads the current by 45 degrees. So then that's why we are going to say potential difference in the circuit by a phase angle of 45 degrees leads the electric current. And fifth one, in an AC resonance circuit is made up of a source. Again, it's talking about the resonance. I talked to you here, what does resonance mean? In resonance circuit, XL is equal to XC. That's why Z is equal to R. But one more result here. So made up of a source, a resistor and pure resistance, an inductive coil and a capacitor. The phase angle difference between the total potential difference and the current in the circuit is what? So then theta is equal to tangent negative 1 XL minus XC divided by R. If XL and XC are equal, which means this is 0, then 0 divided by the number 0. Which angle has a 0 tangent? Of course, 0. So it is a rule in a resonance circuit. So the phase angle difference always equal to 0. You can learn this as a rule too. Question number 6. An AC source is connected across a series combination of 6 ohm resistor, which is R, a coil of pure self with inductive impedance 24 is XL, and a capacitance with a capacitive impedance XC, which is 16. Calculate total impedance. This is very easy. Z is equal to square root of R squared plus XL minus XC squared. So then R is 6 squared plus XL 24 minus 16 squared. This is 8, 6, 8, and answer is 10 ohm. And question number 7. A coil of self-inductance 100 over pi millihenry is traversed by a current of intensity 2 ampere under direct potential difference is 18 volt. This question's first part is talking about direct potential difference. In fact, we didn't study this in the 12th grade. You studied this in the 11th grade. In direct potential difference, if there's a current, so this current only measures from this current you can measure the resistance. Because if potential difference is 18 volt, if electric current in this coil is 2 ampere, which means this coil is not pure. This coil must have a resistance. So until this part of this question, you will calculate what is the resistance of this unpure coil, V over I, Ohm's law. 18 divided by 2, which is 9 ohm. So this coil has a pure inductance and also resistance. This unpure coil will have a resistance RL and also inductive impedance XL. So we got RL, which is 9 ohm, and find the maximum value of the current in the coil when connected across an AC source, effective value 18 volt. And then we are going to attach this to an AC generator whose effective value is 18 volts across a frequency source has a frequency of 60 hertz. Because L is given, which is equal to 100 over pi, we can calculate what XL is here. In XL is equal to 2 pi FL. So 2 pi F is 100 over, F is 60. L is 100 over pi multiplied by 60. Pi will simplify. So then answer, it's also millihenry multiplied by 10 to the power of negative 3. So then answer is 200 multiplied by 60. It becomes, let's multiply them all by the calculator. So 2 multiplied by 100 multiplied by 60 multiplied by 10 to the power of negative 3. 12. So then XL is equal to 12 ohm. To get the effective value, the maximum value of the current, first we should calculate what Z is. Z is equal to, we know that, R squared plus XL squared. So R is 9, square root of 9 plus 12, square root of 12, square root. If you do calculation, you will get the answer as 15 ohm. Z is equal to 15 ohm. And now we are ready for finding what I effective is. V effective over Z is I effective. V effective is given as 18 divided by Z 15. So 18 divided by 15, which is equal to 1.2 ampere. But this is the effective current. Question is asking maximum value of the current. IM is the question. So we should multiply effective value by root of 2. 1.2 multiplied by root of 2. Multiply this value by root of 2. Answer is 1.7, almost 1.7 ampere. So then answer is going to be, here will be the root of 2 multiplication. So 1.2 multiplied by root of 2, choice will be A. In AC circuits, which of the following depends on the frequency of the voltage? We talk about this. Only R does not change with the frequency. All others, XL, XC, and because XL and XC changes Z, this 3 changes by frequency of the AC generator. And let's continue with the other questions. There are some more questions we will do. 9, question number 9. A coil of self-inductance 50 millihenry traversed by the current of intensity 2 ampere under a direct potential difference. It's exactly the same as we did this one. 7 and 9 are similar questions. So that's why if you check the solution of the 7, it's almost the same, the solution of 9, solution of 7. Only numbers are different. A voltage source of instantaneous value of V20 sine 100 pi t is connected across a series combination of a resistor, pure resistor, and pure coil of self-inductance, or point to calculate total impedance. So then you know that total impedance is equal to R squared plus, because there is no XC, only XL squared. First you should calculate what XL is, 2 pi F L, or omega L, only omega L, because here omega is given according to generator equation. V is equal to Vm sine omega t. Here instead of omega, what is written here? 100 pi. So then we will multiply 100. Pi is 3.14. L is, how much is 0.2? 0.2. Multiply them all. 314 multiplied by 0.2, which is equal to 63, almost 63 ohm, which is XL. Now we can get Z. Z is equal to R is given in the question as 100, square root of 100 plus square root of 63, and then get the square root. Square of this number plus, square root of 100. Answer is this. After that, get the square root of the answer. So it's 118. Z is equal to 118 ohm, choice A. And question number 11. A voltage source of instantaneous value, again, is connected across a series combination of pure resistor of 10 ohm and pure inductor of 0.2 to calculate the phase angle difference. This one question. Same question. But here, total impedance is asked. Here is the phase angle difference. So we will use the value, the same numbers here. You know that theta is equal to tangent inverse XL over R. So then, tangent inverse XL is 63. R is 100. Then after let's get the inverse. 63 divided by 100 is 0.63. Shift tangent, answer 32.3. So theta is equal to 32.2, which is choice C. And an inductive coil of resistance of 10 ohm and self-induction of 0.5 is connected in series with the capacitor of capacitance 150. So there are three devices. An inductive coil, but resistance. This is also unpure coil, because normally pure coil has no resistance. So then that's why we are going to represent this coil by inductance and also a resistance. This is the unpure coil. Unpure coil. And this coil is connected in series with a capacitor. Here is a capacitor. And capacitance is given 150 microfarad. C is 150 microfarad. Connected to an AC source of 220 volt. We will connect them to an AC source. Effective value is 250 volt. And then the frequency is 50 hertz. Calculate the effective value of the alternating current. IE is asked. So V is known. IE can be calculated only by calculating the Z. No Z, no IE. That's why first you should calculate what Z is. So XL must be calculated, but RL is given. This coil has a resistance of 10. We will treat it as just a usual resistance. So XL must be calculated, which is equal to 2 pi FL. So 2 pi is 3.14, F is given 50 hertz, L is given in the question as 0.5. So let's multiply them all and get XL. 2 times 3.14 multiplied by 50 multiplied by 0.5 is the 157. 157 ohm. Now we can calculate Z. Z is equal to root of, by the time, of course, we should calculate 1 XC2. This is XL. XC is not calculated. We need to calculate what XC is. XC is equal to 1 over 2 pi FC. So 1 over 2 pi is 6.28. F is 50. C is 150 multiplied by 10 to the power of negative 6 in bracket. Let's calculate XC. 1 divided by, don't forget bracket, 6.28 multiplied by 50 multiplied by 150 multiplied by 10 to the power of negative 6, close the bracket. Answer is 21.2, almost 21. 21 ohm is the XC. Now we can calculate Z. Z is equal to R squared, which is 10, plus XL minus XC. XL is 157 minus 21 squared. Now let's get the answer for Z. 157 minus 21, which is equal to this, but squared, plus 10 squared. Answer is it. After that, get the square root of the answer. 136. Z is equal to 136.4 ohm. Now I effective. I effective is equal to V effective divided by Z. So V effective is given in the question as 250 divided by Z is 136.4. So then we will divide 250 by answer, which is equal to 1.83 ampere. 1.8 ampere is the answer. And we will continue other questions. An inductive coil of resistance 8 ohm and inductive impedance of 6 ohm is connected. Again, coil has a resistance. Is it the same question? No. This coil, inductive coil of resistance, when it says it has a inductance XL and also it has a resistance RL. This is unpure coil. So inductive impedance is 60. So unpure coil. RL is given as inductive impedance 60. So for XL is 60. RL is given as 80. Connected across a source, there is a generator. This generator has an effective potential difference 200 volt. Frequency is 60 hertz. So calculate Z. So in fact, here only thing you should do is to use the equation for Z. All these are given unnecessary. So R squared plus XL squared square root